Hi everybody, and welcome to the next video for the course. In this video we cover what are called if statements, and the big tools for us in this course, the tools that we really need to write sophisticated programs, are these four big things: if statements, loops, functions, and vectors. So today we start sort of the big work of the course. This will be our first really sophisticated tool that will let us write more complicated, fun programs towards the end of the course. So to motivate what an if statement is, I want you to imagine that you're writing a game program. And this game program has a bunch of different games in it. So the user gets to choose what game they want to play. So to set up that code, you might first create a string called response and then ask them, what game do you want to play? And maybe they could type like poker or blackjack or hearts or spades or pinochle or whatever, right? Maybe this is a card game program. Okay, once you get that response from the user, what you now need is a way to take that response and choose a particular branch in the code down which to go. So for example, if the user enters poker, you need to have a way of telling the computer, okay, run the poker code now because they said poker. So you need a way to say, if the user gave me poker, please run poker code. But if the user gave me blackjack, please run the blackjack code. But if the user gave me spades, please run the spades code, etc. So you need a way to allow your program to branch in multiple directions based on user input. So something like this might be what you need. If their response is hangman, do this. If response is blackjack, do this other stuff. If their response is poker, do this other stuff. That's what an if statement allows you to do. So if statements allow for a program to branch in different directions, doing certain chunks of code only if some prior condition has been met. So you can write a bunch of poker code and then set up your program so that that code only runs if the user entered poker. So to get all this going, we first need the idea of a Boolean statement. So a Boolean variable is a variable that can only take on the value true or false. A Boolean statement is a statement that is either true or false. So it's kind of an analogous definition to a Boolean variable. Here are some examples of Boolean statements. X is less than 2. That is either true or false based on the value of x. It's true sometimes and false other times. Here's an English Boolean statement. I am your professor. This happens to be true, but if I were saying this to other students on campus, it might be false. Here are some examples of non-Boolean statements. Hello, right? If I just wave hello to you, that's not a statement that's either true or false. If, in contrast to x is less than 2, if I just say x, that is something that's neither true nor false, right? So if I just say to you 3, okay, that statement of 3 is neither true nor false. Instructions also are not Boolean statements. If I say, hey, please shut that door, that's not a statement that's either true or false. It's just a command. So these are the kinds of statements that we care about for if statements. An if statement needs something that's either true or false. If the statement is true, like say, the user gave us poker, then the computer will do some code based on the truth of that statement. So here's the structure of an if statement. If, and then you hand it a Boolean statement, and then you give it a bunch of code inside of braces. So if the Boolean statement is true, then the program does this stuff that's in here. If the Boolean statement is false, the program does not do code. The program skips right over this. So consider this chunk of code here. Int x is 2. So at this point in the code, x is 2. This says if x is less than 3, then please print to the screen for me, what up? So since this Boolean statement happens to be true at that point in the code, the program goes right into these braces and does what's here. So this code will print what up to the screen. By contrast, if I write int x equals 4, now when we get to this piece of the code, x is not less than 3. So the statement x is less than 3 is a false statement. So when you have something false in here, the program will skip right over what's inside the braces. It will skip right down here to the end. So the braces tell the computer what statements to run as long as the Boolean statement is true. Without braces, only the first line following the if statement is executed. So if you choose not to use braces, the computer puts some in for you implicitly. So if you don't use braces, the first line after the if is inside of braces. So it's like there's an implied open brace right here and an implied close brace here. So even though x is less than 1 is a false statement, this code will still print class because the cout high, that's the only thing that's implied to be inside the if statement. Okay, so we compare an if statement with an else statement. In English, you should read else as otherwise. So consider a chunk of code like this. We get an integer from the user, right? So they're going to enter 5 or -30 or something. This code in English reads as, if x is bigger than 0, then print to the screen your number is positive. Otherwise, print to the screen your number is not positive. So let's just go ahead and put that in here. So int x cnx. If x is positive, then tell the user that. Otherwise, tell the user number is not positive. Oops. So let's just make sure this works. I will enter a -5, and it says number is not positive, right? Because right here, x takes on the value of -5. -5 is not bigger than 0. So this is a false statement. So other than doing this, the only other choice is this else. Okay, so the way that if-else really works is it gives the code 2 mutually exclusive branches down which to go. So if the if statement code doesn't run, in which case this, the else stuff will run. Okay, so you're giving the code 2 choices to make as to where to go, and they are mutually exclusive. You will only travel down one branch. And which branch you go down all depends on this Boolean statement here. So if x is positive, it will tell you your number is positive because it travels down this branch. But if x is not positive, the code is forced to go down this branch. Okay, analogously, you can have what's called an else-if statement. So imagine, for an example, I'll do an example here with temperature in a second, but numbers aren't just positive or negative. There's a special case, which is 0, okay? And so you can imagine setting up a program in which you want 3 distinct branches. You want that if x is positive, output positive. Otherwise, if x is negative, then say number is negative. Otherwise, say number is 0. So the way that this structure works is now we've given the computer 3 mutually exclusive branches down which to go. So if x is positive, it will go down this branch, and then it won't even look at the further branches. It skips over these 2. If x is not positive, it now goes to this else if, or in English if you like, otherwise if, and tests whether or not x is negative. If it is, it prints this out and then skips to the very end. So anytime you do one of these branches in an if, else statement, you always skip right to the end when you're done. These branches are all mutually exclusive, okay? So that's how an if, else structure works. So let me now do something with temperature. So let's just, let's ask the user, what's the temperature outside? And for your physics people, we'll just assume it's all Fahrenheit, because I'm not a physicist, I like Fahrenheit. So let's say that if x is, let's say, bigger than 80 degrees, cout shorts weather, right? Shorts and t-shirt weather. Else, if x is bigger than, oh, I don't know, 65, say shorts, but maybe a jacket. Otherwise, if, so you can keep adding these, you know, X is bigger than 45. Oops. Pants and jacket. Otherwise, coat weather. Okay, so let's think about the logical structure of what's happening here. Why, oops. So we're going to get a number from the user. If that number is bigger than 80, we run this line of code and then skip way down to the end of this entire if-else-if block here. Because all 4 of these branches here are mutually exclusive. You do at most one of them. So if x is bigger than 80, you will do this and skip to the end. Okay, so let's just run that and make sure that's what happens. What's the temperature outside? 95, man, pretty hot. Oop, shorts weather, okay. So notice it worked just as I said it would work, which hopefully is usually the case. Usually I tell you correct things. Okay, so notice though that if x is 95, well 95 is bigger than 65, right? 95 is bigger than 45. So why don't all 3 of these blocks of code run? Do you see what I'm saying? Each of these 3 statements is true. So why don't we just run all 3 of them? And the answer is because, again, this setup lets you set up mutually exclusive branches down which the code can go. So you can never go down more than 1 branch if you use this if, else if, else if, else if setup. Now, if I take out this else and just write an if there, then now the computer sees this as an if statement and then this as its own separate if, else block. So now, if I say, what's the temperature outside? 95. It says shorts weather, and then it also says shorts, but maybe a jacket. Because it does this if statement, and then it's done with this if block. There's no else or else if coming after it. Now it goes down to this if statement, and this if block gives it 3 different branches down which it can go. Okay? So you see the difference between this and this? If you type else if here, now you're connecting this back up to this original if statement. So this is now like a single block of code, and you're giving the computer 4 branches down which to go. If you take this else off, now you're just giving it a single if statement. This is 1 block. And then here's a new other if block. So this takes some getting used to. Essentially, you just have to play around with this till you get comfortable with what it's doing. But once you write if, you can write as many else ifs, whatever after it, and that's all a single block. And the computer just starts at the top and works its way down and only does 1 branch. Notice also, okay, let me put this back. Suppose I take this else out of there. So now I say if x is bigger than 80, shorts weather. Otherwise, if x is bigger than 65, this. Otherwise, if x is bigger than 45. But now there's no else at the end. I'm going to enter here the number 30. If I were sitting with you face to face, I would ask you to predict what happens. If you think about it for a second, you would realize nothing happens. Because when you set up otherwise if, you're giving it more Boolean statements to check. And so if every single time you're giving it a statement to check and none of them is true, it just won't run any of this code. It just skips past all of it. So when you have an else down here, this is just a catch-all thing for anything else. So now any number you give that's below 45, it will say too cold. Okay, so again, an if, else structure allows you to set up as many different branches of code as you want, and the computer will choose at most 1 of those branches. Whenever you have an else, the computer will choose exactly 1 of those branches because you've given it sort of an out down here, like, well, if none of these work, then you at least must do this, okay? So if you have an if and then an else at the end, you will go down exactly 1 branch, exactly 1. If the else is gone, you might not go down any of the branches. Okay, you might just skip past all of this. It depends on the value of x as the computer checks these conditions. But you will go down at most 1 of these branches. So notice if I basically change the order of these, let me put the 45 here and the 80 here. Let me go ahead and switch everything. The computer always works from top to bottom. So now, if I enter 95, well, 95 is bigger than 45, so it's going to say pants and jacket and then stop. Because, again, you can only go down at most one branch, and you work from the top down. Okay, so that's a basic introduction to how if statements work. If and also else if and also else. So here are some things you can use in Boolean statements. The greater than symbol means greater than, as you would expect. The less than symbol means less than, as you would expect. If you want to write greater than or equal to, not greater than, but greater than, you write greater than and then equals. If you want to write less than or equal to, you write less than, followed by an equals. If you want to write equals, okay, this will bother you, like other things will bother you, but in a Boolean statement, the way you write equals is with a double equals. So back up here, if I get something from the user, I can write if x equals to, say, x is 2. So now if I run this, if I type in 2, it says x is 2. If I enter anything else, it just doesn't do anything. Okay, it skips right past that. But you need this double equals in here for this to run properly. This is a Boolean equals. And if you want to write does not equal, it's exclamation mark equals. So as I say here, don't confuse double equals with single equals. X equal to is a Boolean statement. It's basically asking, is x equal to 2? So it tests whether or not x is 2. And then based on whether x is 2, it runs some code. X equals to is not a Boolean statement. It's actually a command. The computer reads this as, oh, make x equal to 2. So the computer is no longer asking a question, is x equal to 2? The computer now just sees this command and sets x equal to 2. So if you write this, if x equals 2, the computer will just set the value equal to 2, and depending on your compiler, this is what it does in mine, it just runs the if block no matter what. Okay, so you need to make sure that inside of your if parentheses, you have a Boolean statement. And a single equals is not a Boolean statement. It's not asking the question whether or not x is 2. It's just setting x equal to 2, and then it will most likely just do what's in the if block, no matter the value of x before this. Oh yeah, okay, so now let's actually do my game example. Where was it? Yeah, if response is hangman, do this, blah, blah. Okay, so the way you would set that up is string response. So cout, what game do you want to play? And then I always add an inline just to make sure things are formatted a little more nicely. And now depending on, maybe you have some games with more than one word in them. So remember, if you're getting more than a single word from the user with a string, you have to use this getLine command. And so here, if you want them to play poker, you can now write, okay, if response is poker, then poker code, however you write that code. So just to test this in a second, let's just put let's play poker in there. Otherwise, if response is blackjack, and notice I'm using the double quotes for strings, okay, not single quotes like for characters. Cout, okay, blackjack it is, etc. Depends on how many games you have. Else if, let's just do one more. Response is, what's another card game? Hearts. Cout, time to play. And let's just put a catch-all thing down here at the end. Otherwise, if they don't enter any of these things, let's just tell them I don't recognize what you told me. Okay. So again, for all of these, you actually type. This is far beyond us right now, right? But you would actually put code for all of these games in here. Okay, so let's see how this works. What game do I want to play? I'm in the mood for poker. Let's play poker. Okay, so I entered exactly this, poker. Let's run this again. I want to play blackjack. Blackjack it is, okay, and that's all it responded. Let's run this again and let me put poker like this, as opposed to, a second ago I typed capital poker like this. Let's put lowercase. It says I don't recognize that game. And you might be confused as to why that is, because clearly I typed in poker. It's supposed to say let's play poker. So let me just remind you again that computers are idiots. They see no shades of meaning. Okay, there's no ambiguity with them. They will do exactly what you tell them. So right here I told it if response is poker with a capital P, then output some stuff. If response is blackjack with a capital B, do some stuff. If response is hearts with a lowercase h, do some stuff. Otherwise, say I don't recognize that. Okay. So next time we'll talk about doing multiple Boolean statements at the same time. So here you probably would want something that says, well, if response is poker uppercase or poker lowercase, then let's play poker. Things like that. So we'll talk about other Boolean statements you can put in. We will also talk about using if statements inside of if statements. But for now, here is an introduction to if statements.